Geotechnical engineering. This is of two types, that is soil mechanics and foundation engineering. In soil mechanics, we will be learning about physical properties of the soil, index properties, engineering properties, that is permeability, compressibility and shear strength. And in foundation engineering, we are gonna study about the earth pressure theories, stability of slopes, foundations, that is shallow foundation and deep foundation. Next, coming to the origin of soils. Soil is a loose unconsolidated material formed by weathering of rocks and decomposition of the organic matter. And soils formed by weathering of rocks are called as inorganic soils. Those are example clay, silt, sand and gravel. Next, soils formed by decomposition of organic matter are called as organic soils or cumulose soils, another name. And the process of formation of soils is known as pyrolysis. Pyrolysis is the process of formation of soils. Next, soil mechanics. Soil consists of solids and voids. Voids means space. Voids may get filled with air or water or both air and water. Mechanics that deals with action of forces or soil solids and flow of water through the soil. And this is termed by the Carl Terzaghi. He is the father of geotechnical engineering. Next, coming to the origin of the soils. First, weathering and decomposition of organic matter. In weathering, there is physical weathering and chemical weathering. Physical weathering means temperature, wedging action of ice, root plant growth, abrasion. And chemical weathering means hydrolysis, carbonation, reduction of clay and oxidation. Examples of the physical weathering is gravel, sand and silt. Examples of the chemical weathering is clay. And one more important thing, in physical weathering, the properties of soils are same as its parent rock. Physically it is coming, no? So because it will be same as its parent rock. And next one, in chemical weathering, the properties of soil are different than parent rock because it is chemically weathering process. Next one, geological cycle is, first rock is there. Rock, weathering, transportation, deposition and upheaval. These are the geological cycle process. And upheaval after, next, from sun to rock, weathering, transportation, deposition and uphill. Next one, residual soils. Residual soils means the soils that are deposited at the place of its origin is called as residual soils. This is important one. Next, transported or sedimentary soils. That means soils that are deposited away from its place of origin is called as transported or sedimentary soils. Next, based on transporting agents, first one, air or wind, that is alien deposits. Example, sand dunes, Lewis, silt, silty deposit. Next one, water. From water, still water, running water, marine water. Still water means from lakes, that is called as lacustrine deposits, and running water from rivers, that is called alluvial soils, and marine water, that is called marine soils. This is also very important. This will be asking in match the following also. Next one, from based on the transporting agents, third one is glacier. Glacier deposits, example till and drift. Next one, fourth one, gravity means colluvial or alluvial deposits, that is example talus. So based on the forces, there is body or gravity force. Next one is surface force. First one, a body or gravity force means these are predominant in gravel and sand. Next, proportional to the mass. Next one, from surface force, these are predominant in clay and proportional to specific surface area. So what is specific surface area? Specific surface area means surface area by volume is called as specific surface area. Surface area units is meter square, volume units meter cube. So meter square gets cancelled, so is equals to 1 by meter. Next, specific surface area, that is clay is greater than gravel, that is surface area by weight, meter square by weight units kilonewton, meter square by kilonewton. In silts, both body and surface forces are predominant. Next one, coming to the field terminology. Coming to the field terminology, that is types of soils. There are 5 types of soils. Those are loamy soils, moram, that is red soil, warwood clay, black cotton soil, and bentonite clay. So first one, we will be learning about the loamy soil. What is loamy soil? Mixture of sand and silt and clay is called as loamy soil. Each component should be less than 50%. So these loamy soils are best suitable for agriculture purpose only. Example, a soil consists of sand is 55%. As we have told, loamy soil means it is the mixture of sand, silt and clay. No, so in these three have some percentages, that is sand is around 55%, silty is around 25%, and clay is around 20%. As sand is equals to 55% or greater than 50%, so mixture cannot be loamy. So that is clay percentage is less than, silt percentage is less than sand. So this is called as clayey, silty sand. Next one is moram or red soil. Red soil means it is a mixture of gravel and red clay. So these gravel and red clay. So this red soil is best suitable for WBM roads, that is water bond macadam. This is a traditional way, that is the cost effective way. And third one is warwood clay. Warwood clay means alternate thin layers of silt and clay is called as warwood clay, and it is a lacustrine deposit. Next one, black cotton soil. Black cotton soil is chemically weathered residual soil, that is parent rock, that is called as basalt. It has a high swelling and shrinkage property due to the mineral called montmorillonite. Next one, bentonite clay. Bentonite clay means volcanic ash. It has high swelling and shrinkage property, that is bentonite slurry. Bentonite plus water clay is called as bentonite slurry. As this is soil, this is bentonite clay, this is ground level, and below this bentonite clay is there. So this is called as bentonite plus water clay, bentonite slurry. Next one, coming to the organic soil. Organic soil means humus, peat and muck. Humus means partly decomposed organic matter that is amorphous in nature, and peat means fully decomposed one, and muck fully decomposed plus some fine inorganic soil. Next one, cohesive soil, cohesion less soil. Cohesive soil means clay. Cohesion less soil means silt, sand and gravel. As C, this will be in micrometers, that is 24 micrometers, 75 micrometers and 4.75 micrometers. Below this is called clay, and between this it is called silt, and between this it is called sand, and greater than 4.75 is called as gravel. And also we can see that is D less than or equals to 74 micrometers is called as fine grain soils. As there will be one sieve, in that sieve if we sieve, if that is passing through 4.75 microns, then that is called as sand, and if greater than, that is called as gravel. Like this, the fine grain and coarse grain soils also classified in this way. As D is less than or equals to 75 micrometers is called as fine grain soils, and D is greater than or equals to 75 micrometers is called as coarse grain soils. And this is about the basic introduction and basic thing that of geotechnical engineering, that is the origin of the soils. And in next lecture we will be learning about the physical properties and definitions of the soils in deep way. Thank you.